So we've got an integral here, it looks pretty tricky. We've got x squared divided by square root of 3x plus 2, integrated from 0 to 2. Now, usual way here would be use substitution with the contents of this radical here, 3x plus 2, and then go from there. And you're probably going to need 1 or 2 more substitutions to get to the answer. Now I'm going to leave that for you guys to have a go at, but there is another way we could do this. And we can see here this x squared term on the top is the one that's causing all the difficulties. But there's a way of getting that out of there by using a power reduction formula. Now, for an integral of this description here, we can set this up in power reduction formula kind of terms. So this integral here, so we won't worry about the parameters at the moment, let's just worry about the actual integrand itself. This would take the format of x to the n, where n is the power of the integrand, and then this radical here, which would be ax plus b. Now, if we look at our integrand here, we can see that n would be 2, a would be 3, and b would be 2. So that's the kind of format we've got here. Now, for an integral of this kind of manner, we've got the power reduction formula, which we can write down here now. So I subscript n, which is pretty standard for power reduction formulas, integral of this power. So this case it would be I of subscript 2. So that would equal 2 times x to the power of n, and then the radical at the side of it, and then in the denominator I've got a times 2n plus 1. So that creates some kind of multiple when we get to the end. And then this radical here, we just multiply everything by it. So here we'd have ax plus b, just to give you the general formula. So in this case it would be 3x plus 2. And then from that, we subtract that with the constant multiple for another integral. So it's 2n times b, and then this denominator here repeats, and then we end up with a new integral. So that's the constant multiple for the integral. And then again, we're not going to worry about those parameters for the moment. We can put them in when we have a go at getting the result for this one. So then we get a new formula for the integral, which is x to the n minus 1, hence power reduction, power is reduced by 1, x to the n minus 1, and then the integrand keeps the same radical. So that stays. And again, it's with regards to x. Okay, now we can work out what this is for our integrand by just plugging those values into this formula. And that's how we use a power reduction formula. So let's go ahead and do that. So if I go for I subscript 2, that's what our integrand requires, as it's x to the power of 2. I've got n is 2, a is 3, b is 2. So let's plug all those in there and see where it takes us. So now we've got 2x to the power of 2. A times 2n plus 1, so that's 3 times 2 times 2 plus 1, so that's 3. Let's just write it out, 2 times 2 plus 1. We can see what's going on. We can calculate those in a moment. And then the radical will stay, and as you can see here, the radical stays the same all the way through. So we don't have to worry about that for the moment. Okay, now as that's part of our answer, and we've got a definite integral, this has to be calculated over the range of integration. So that's from 0 to 2. Okay, now new integral minus 2 times 2 times 3. Times 2, sorry, b is 2. And then a times 2n plus 1, which is the same as this. So that's 2 times 2 plus 1. And then set up the new integral with the reduced power of reduced by 1. So I'm going to write that there as x to the power of 1. Obviously we can see that's x. And we still have to use our parameters of integration, and then the radical stays the same. So that's what we end up with there. So you can see here there's a new integral to take care of. Okay, right. So now let's just simplify this up a little bit and just clean up these calculations. So I've got 2x squared. I'm not going to calculate the value of this just yet. I'm going to do that at the end when I've got all the results. So here I've got 2x squared, and that's divided by 2 times 2 is 4 plus 1 is 5 times 3, that's 15. And our radical, 3x plus 2, calculated from 0 to 2. Okay, so now I've got a constant multiple. So I've got minus 8. This one calculates the same as this one, so that's going to be 15 as well. And then the integral from 0 to 2, x over square root of 3x plus 2 dx. Now I'm going to put the 1 there, leave it as power of 1, because I still need to integrate that one. Now that is almost the same format as there, but with the power reduced by 1. So I can plug this part here into this power reduction formula again and see where that takes us. So this one will just carry down. So I won't bother writing that out again just yet. But I've now got a constant multiple for all of that. So I've now got minus 8 over 15. And let's go again through this with this integral here. So I've got 2x to the power of n. So that's now just 2x, because x is to the power of 1. And here I've got 3 times 2 times 1 plus 1. 3 times 2 times 1 plus 1. So n is now 1 in this one. So let's just plug those in here. So now n is 1, a is still 3, and b is still 2. So that's what we've got there. Okay, so the radical continues. So I've got the square root of 3x plus 2. So this bit here is part of our answer, and as this one was, we have to calculate this over the parameters of integration. So that's from 0 to 2. So that little bit there, just keep on its own. And then we've got to subtract this new integral. So minus 2 times n times b, 2 times 1 times 2, 2 times 1 times 2, and then a times 2n plus 1, which is the same as this one. So 3 times 2 times 1 plus 1, and then a new integral. So from 0 to 2, and now the power is reduced by 1, so this x to the power of 0, obviously that's going to change to 1, n to the power of 0 is still 1. So I'm going to write this x to the 0 for now, and keep the radical. So square root of 3x plus 2 dx. Okay. Right, now let's start a new line and let's just simplify things off a little bit. So 2x squared over 15 times our radical, 3x plus 2. Now this one here will form part of our answer over those ranges of integration. So I'm going to stick that alongside here. So I've got minus 8 times 2x, that's minus 16x. And 15 times 3 is 45, and 2 ones are 2 plus 1, that's 3, so that's going to give me 135, and my radical will stay. So that's all calculated from 0 to 2, and then I've got this new integral here. So minus 2 ones are 2 times 2 is going to give me 4. So 4, don't forget minus 4, and minus 8, still multiplying all of this, that's going to give me plus 32. So I nearly missed that there. And here I've got 3 times 2 times 1 plus 1, so that's 2, plus 1 is 3, 3 3s are 9, 9 15s, 135. Okay, and then the new integral, which I'm just going to write in there from 0 to 2, x to 0 is 1 over my radical. Okay, now that's looking like we're getting to the end of the integration, because that looks much easier to integrate. So that's what we've got so far. Okay, right, I'm going to clear some space on the board, and then let's see if we can get the result of this and then calculate our answer. Okay. Okay, right, let's see if we can continue with this. So this is all good, we just need to plug in the values and find our answer. Just need to deal with this integral first. Now, instead of integrating this, why don't we just take a shortcut and use the fundamental theorem of calculus, where the integral of the derivative is the same as the integrand. So let's work on that. So let's imagine we've got this radical here. We just take the derivative of that radical in a numerator. There's no denominator. So if we take the derivative of that, we'll get 1/2 times square root of 3x plus 2 and then using the chain rule, multiply by the value inside the radical. So the derivative of 3x plus 2 is 3. That's going to give me 1 times 3 over 2, so it gives me a multiple of 3 over 2. Now here we don't have a multiple of 3 over 2. I want to try and eliminate that. So if I multiply that by 2/3, I can then eliminate that multiple. So therefore my result of this integral here, if I do 2/3 and then write square root of 3x plus 2, that's going to give me my answer. So let's put that in there and clear this off the board. Okay, so let's put our result of that in. So it's 32 over 135, and then multiply that by 2/3, and then the square root of 3x plus 2. And that's calculated from 0 to 2. And you can see now we can do all of it calculated from 0 to 2. So let's just write it all in there. So 2x squared over 15, square root of 3x plus 2, minus 16x over 135, square root of 3x plus 2, and this one here, all from 0 to 2. Okay, well, let's evaluate it at 2, plug in our values, see where that takes us. So 2 squared is 4, so that's going to give us 8 over 15. So that's 8 over 15. Square root of this, x is 2, so 3 2s are 6 plus 2, that gives me 8. So that's square root of 8. And then minus x is 2, that's 32 over 135. Oh, let's write 135, not 155. Square root of 8. That's always going to be. This one we can just clean it up a little bit. So that's 64 over 405. So that's plus 64 over 405. And square root of 8. That's going to stay. Okay, so that's the value at 2. So now we need to subtract the value when it's 0. Well, that'll be 0, because x is 0, so they'll all disappear. This one here, slightly different. X is 0, we're going to get square root of 2. And this multiple will still stay the same. So minus 64 over 405, square root of 2. Okay, right. Now, I can factor out a square root of 8 if I like. Let's do that. So square root of 8. And common denominator here, I've got 15, 135 and 405. So let's call that 405. So how many 15s in 405? Well, there's going to be 27 if I remember correctly. 3 15s are 45, take that off 30, that's 27. So that's square root of 8 over 405, and then 8 times 27, that's going to give me 216. So that's fine, that takes care of that. Okay, now what about this one? 135, so I need to multiply by 3, so that's minus 96. Square root of 8 is still there, so that's minus 96. This one here, 64, 405 stays, so I've got 64, square root of 8 has gone out, so that's plus 64. Okay, let's have a look at this one. So this one's square root of 2, so minus 64 root 2 over 405. Let's just put that in there. Okay, 216 minus 96 is 120, so that's going to give me 184. Okay, and this one here, that stays as it is. So let's plug all that into a calculator and hopefully you'll get something that's approximately 1.06 and some more. So that's the value of this integral using the power reduction formula. Okay.